All right, we are going to spend many days talking about factoring, which is something that should have been covered in Algebra 1, but we are going to cover it even more in depth in Algebra 2. So for day 1, our objective is going to be to factor out the GCF, also known as the greatest common factor, and also to factor the difference of two squares. All right, 4 bullet points to write down for our notes. GCF stands for greatest common factor. Before doing other types of factoring, which we will cover later, you must always check for a GCF first. The GCF is the greatest factor that divides evenly into each term. And we think of this type of factoring as undistributing. On each of these, we are going to factor out the GCF from each polynomial. The first one, 6x minus 10. One of the first things we need to do is identify what the terms are. How many terms do we have in number 1? 2. Okay, 6x is one term, 10 is another term. So we are trying to find a factor or a number or a term that will divide both of those terms evenly. So what could I divide into both of these terms evenly?
2.
Chris? 2. So if I could divide both of these by 2, then 2 comes out in front of my parentheses. Remember, we're thinking about this as undistributing, dividing evenly. So if I take 6x and divide it by 2, who can raise their hand and tell me what I would get? Emily? 3x. We're going to keep that symbol in the middle the same. We divided by a positive, so it's not changing the signs. And 10 divided by 2 is 5. Now, as long as we use the GCF from the beginning, which we did, then these two terms left inside the parentheses should be relatively prime, meaning that we can't divide both of those by anything other than 1. So this would be our answer. We could check ourselves, because if we do distribute the 2 into the parentheses, we should end up with the original problem. Questions on 1? All right, on number 2, can anyone raise their hand and tell me what they think the GCF might be? Charles? I think 2 is part of it. Sadia, do you know the other part of it? X. 2x. We have to look for a variable that can also divide into all of those. We look for the biggest power of that variable that all of the terms have. So I could not use x squared because the last term just has x to the first. So I use the biggest possible one that all of the terms can handle. In this case, that's just x to the first. So 2x to the first. That goes outside the parentheses. So then I go one term at a time to see what goes inside the parentheses. Can anyone raise their hand and tell me what I get if I take 2x cubed divided by 2x? What is it, Devin? What is it? 1x squared. Very good. 2 divided by 2 is 1. X cubed divided by x is x squared. So 1x squared. If you do not put the 1, that's okay. You can just write it as x squared. Minus. I keep that sign because dividing by a positive is not going to change the sign. Can anyone raise their hand and tell me what 6x squared divided by 2x equals? Izzy? 3x. Very good. Again, keep that plus sign. Bring it over. And then we have to take 14x divided by 2x. Looking for new volunteers. Keaton. What's 14x divided by 2x? What's 14 divided by 2? Let's start with that part. 14 divided by 2 gives me 7. All right, and then x divided by x. 1, right? They cancel each other out, so they kind of just go away. They equal 1, so we don't have to write them. So I'll move my ending parenthesis in, and then we are finished with that one for now. That is factoring out the GCF. All right, on example 3, who thinks they know what the GCF is? Caden. Anything you want to add to that? 4x squared, very good. We use the largest exponent that we can handle. So both of them have at least an x squared in them, so that's what we would use. So whatever you're dividing by is what goes out in front of the parentheses. Whatever you have left after you divide goes inside the parentheses. Everyone should know that 4 divided by 4 is 1. We subtract our exponents. So x cubed divided by x squared would give us x to the first power, or just x, minus 1. 4 divided by 4 is still 1. X squared divided by x squared is also 1. So I'll move those parentheses in again. Questions about factoring out a GCF? Oop, except I didn't write it correctly. There we go. Whatever you divide by comes out in front of the parentheses. Whatever's left after you divide stays inside. If we were to distribute, we should end up with the original problem. All right, we're going to do these a little out of order because I want you to have a chance to come to the board, a couple people. So let's do number 5 first because 5 and 6 are pretty similar and we haven't done one like them yet. So on number 5, we first have to decide a number, the greatest common factor number-wise, that'll divide into 36, 18, and 72.
18.
Devin, what'd you come up with? Never mind. Charles? Oh, I'm sorry, I didn't hear it. What is it?
But it's wrong. I put, you got the wrong answer.
Well, what's the right answer?
18.
18. Okay, so we can divide all of them by an 18. Then move to the x. What's the biggest power of x that we could divide by?
X to the first power.
X to the first power. The first term has a squared, but the other two just have plain old x. So that's the biggest one that it can handle in all of the terms. Then look at the y's. What's the biggest power of y that all the terms could handle? Also just the first power. So when you do these, it's kind of like doing 3 problems in one. You gotta think about the number, the x's, and the y's, and piece it all together. So then we go to write our answer. We know that in front of the parentheses we'll have the 18xy because that's what we divided by. Inside the parentheses is whatever's left after we divide by it. 36 divided by 18. I should probably start writing a little smaller. X squared divided by x. Y divided by y.
0.
Alright. It's a 1, right? So they just kind of cancel each other out. On the next one, we've got a minus sign. 18 divided by 18
1.
is a 1. X divided by x,
1, but
1. It cancels. Y squared divided by y
y.
is a y. Plus
4.
72 divided by 18 is 4. X divided by x
Cancels out.
0.
cancels. It's not 0.
Why?
It's technically a 1, so don't say 0. They cancel each other out. Technically, it would equal 1. And what about y divided by y?
Cancels.
Cancels.
Yes.
Okay, or it equals 1. So I guess I didn't have to start writing too much smaller. So there is our answer. 18xy times the quantity 2x minus 1y plus 4. It's not pretty, but that's what it is. When you end your problem, if you end up with a GCF between all of these numbers, say you'd only divided by 9 instead of by 18, then all of these numbers would still have a common factor that you would then have to take out. So that's a way you can check yourself to see if you really got the GCF. When we get to the end, what's in parentheses should not have anything in common with all three terms. Okay, the front and the back have a 2 in common, but the middle doesn't. On number 4, we discussed that our GCF is 6y. So our answer would be 6y times 3y squared plus 1y minus 2. And on number 6, we said that our GCF is 12x squared y. So that's what we are dividing by. Our answer would be 12x squared y times 1y cubed minus 4x plus 12x squared y. It's a long answer. Our other topic for today is going to be the difference of two squares. So to start off, we are going to FOIL or multiply x plus 2 times x minus 2. We talked about this a little bit when we first started chapter 5. Some people did not learn this as FOIL, which if you didn't, that's fine. FOIL stands for first, outer, inner, last. I prefer to think about it as double distributing, meaning that we're going to take this x term here in the first set of parentheses and distribute it to the second set. We're also going to take this 2 in the first set of parentheses and distribute it to the second set. So let's do that. What is x times x?
X squared.
X squared. What is x times negative 2?
Negative 2x.
What about 2 times x?
2x.
Positive 2x. And 2 times negative 2?
Negative 4.
Is negative 4. When we go to simplify that, which terms can combine?
The negative 2x and positive 2x, but they cancel out.
Very good. A negative and a positive of the same term goes to 0. That equals 0. So we are left with x squared minus 4. So this is kind of just a refresher before we get into our rule for factoring these. Questions on that first one? Okay. Let's do another one then. 3x plus 5 times 3x minus 5. Again, we can think about this as double distributing. What is 3x times 3x?
9x squared.
9x squared. 3x times negative 5.
Negative 15x.
Negative 15x. What about 5 times 3x?
15x.
Positive 15x. And 5 times negative 5.
Negative 25.
Negative 25. What happens on this one?
They cancel out.
What cancels?
The negative 15x and the 15x.
All right, once again, our x's cancel out to 0. Positive and a negative of the same thing. So we are left with 9x squared minus 25. Questions about that one? Okay, so the question next asks, what do we notice with those two problems?
The X cancels out.
Okay, so on both of these, the X term cancels out. So the X term cancels. What do we notice about the original problem? What's opposite? The signs. So when we solve these, or when we multiplied them out, the X term canceled. And the original problem, they were the same except for the signs. Same. Yeah, the sets of parentheses were the same except for the signs in the middle. One was positive, one was negative. Okay. Questions about those two things? If you didn't notice them, hopefully you see them now. All right. So we can factor the difference of two squares by working backwards. Factor the difference of two squares by working backwards. All right, so here are our examples. Anytime you notice that your middle term is gone, I would check to see if you can do a difference of squares. So, we know we're going to have two sets of parentheses. We know that the first two terms should multiply to give us an a squared. What would those terms have to be? A and A. Those are the only two things that we're going to be able to multiply together to get us an a squared. What should my signs be in between?
Negative and positive.
Okay, one's got to be plus, one's got to be minus. It does not matter if you do the minus first, then the plus. That's fine. And then we know our last two terms have to be the same thing to multiply to a 16.
4 and 4.
4 and 4. Well, are 8 and 2 the same? No, 8 and 2 are not the same, so that wouldn't end up working. The only reason this works is because that middle term cancels out. If we were to use 8 and 2 instead of 4 and 4, we'd end up with a 6 instead of it canceling. And then we're done. That's it. That's our answer. That's how we factor that. The other way you'll hear this phrased is that we take the square root of the front and the square root of the back. If that helps you remember how to do it, go for that. Use it. That might help us on the next one. Right? Square root the front, square root the back. So I know I'm going to have two parentheses. What's the square root of 9?
3.
3. So that's going to go in the front on both of them. What are my signs going to be?
Plus and negative.
Plus and minus. They got to be different signs. And then the square root of 4b squared
2b.
is 2b. You got to have both parts of it, 2 and the b. Make sure we know that these are b's and not 6's. 2b, 2b. Questions so far?
No. It's like freshman year.
Yes, this is from freshman year. We just have to review it. All right, on the last one. Again, if it helps you figure out what your terms are, put those little square root signs over your problem. What's the square root of 25a squared?
5a.
5a. What are my signs?
Negative and positive.
Negative and positive. What about the square root of 49b squared?
7b.
7b. 7b. Do we have questions about how we're coming up with the 5s and the 7s? All right. Hopefully we're all familiar with our perfect square numbers. If you don't have perfect square numbers, this is not going to work. Okay, so for example, something that will not work for this would be something like a squared minus 3. Okay, we're not going to do difference of two squares on this. If we did, our answer would have to have square root signs in it. Right? There's not a perfect square root to 3. Do we see how that's different from what we did here?
Yeah, it's way different.
Okay. All right, on number 10, when we did that, we should have gotten f minus 8 times f plus 8. Or again, if you switch your signs, plus, minus, that's fine. It's the same thing. One's got to be plus, one's got to be minus. On number 11, we should have gotten 11 plus 9r and 11 minus 9r. Number 12 was a little tricky because our last term had an x to the 6th and our first one had an a to the 4th. Those can still be square rooted. So on this one we should have gotten 4a squared plus 7x cubed and 4a squared minus 7x cubed. Okay, remember if we multiply a squared times a squared, we add the exponents. That gives us that a to the 4th. X cubed times x cubed, we add the exponents. That's how we got that x to the 6th. All right, our last 3 problems. These ones are a little tricky because I believe they involve both ways of factoring that we talked about today. Which way of factoring should we check for first?
Excuse me.
Greatest common factor, the GCF. That's the one we always want to look for first. So, is there anything that we could divide both of these terms by on 13?
3.
A 3. So that's what we should do first. Divide them both by a 3. When we do that, what do we have inside the parentheses?
X squared minus 26.
X squared minus 25.
Oh, sorry. I don't know why I said 26.
It's all right. We got it. But then what do we notice about x squared and 25?
They can be they can be the other factoring thing that we just did.
Good. We can factor that the other way we just did. So that's the difference of two perfect squares. X is a perfect square. 25 is a perfect square. We are subtracting in the middle. So when we do that, the 3 that's out in front, it stays out in front. We don't drop it off. It continues to hang out with us. What term is going in the front of both of those?
X minus
And what about the back?
X.
Oop, what about the back of both of them?
Oh, 5.
Oh. Good. 5 and 5.
1.
One's positive, one's negative. So on that one, we could do both ways of factoring. Questions about 13? All right, on 14, do we have a GCF? No, so we can go to our other way of factoring for this one, the square rooting. What is x, the square root of x to the 4th?
X squared.
X squared. So we have x squared. We got a plus, we got a minus. What's the square root of 81? 9 and 9. But on this one, we might notice that in the back here, we again have perfect squares. And we are again subtracting them. If you are adding perfect squares together, there's nothing special about it. You got to leave that alone. So the x squared plus 9 is not changing. But in the back, the x squared minus 9, we can do the square roots again. What's the square root of x squared?
X squared 4x.
The square root of it would just be x. What's the square root of the 9? 3. So on this one, we have 3 sets of parentheses as part of our answer. Questions on 14?
No. Wait, so you had to have it like one box done?
Yep. We got to take it all the way to the end, as much factoring as we can possibly do. If we just stopped here, we didn't factor as much as we could. On 15, do we have a GCF?
Yeah.
Yes.
What is it?
2x.
2x. When we factor out a 2x, what are we left with?
X squared minus 25.
And what do we notice about x squared minus 25?
Factor and factor.
We can factor it. So we have 2x out in front, and what goes in my parentheses?
X minus 5 and x plus 5.
Good. X minus 5 and x plus 5. And yes, again, we got to take it all the way to the end of the problem. Otherwise, we did not factor it completely.